Now, we can also use tangent to find a length of a side. Okay, so here's my angle. So I'm going to do tangent 31 degrees, and I'm going to put that over 1. Tangent 31 over 1 equals the opposite leg. That's way over here. The opposite leg is 17 over the adjacent leg, which is x. Okay, so we have a proportion to solve. Tangent 31 is to 1 as the opposite leg is to the adjacent leg. Now, something that we learned about proportions in the past is that we can always just switch things that are diagonal from each other. So this is the same as x over 1 equals 17 over tangent 31. Okay, now I've got two ways that I could solve this. One is using this table of trigonometric ratios. Tangent 31 is 0.6009. So 31 and then the tangent column, 0.6009. So I can actually replace this with 0.6009. Oops, 0.6009. Okay, so I could do 17 divided by 0.6009 and get 28.29. So I get x equals 28.29. Okay, now if you have a calculator with a tangent button, the first thing you want to do is check the mode, and degrees has to be highlighted. If either of these two are highlighted, this will not work out correctly. So degrees has to be highlighted, and it is, so we're ready to go here. You might also have right here it says DEG, so we know we are in degrees mode. Okay, so I could type in 17 divided by tangent 31, and the calculator already knows that tangent 31 is 0.6009. And when I divide, I get 28.29, just like I had already. Okay, so we're going to do a couple more like that. So I've got 63 degrees here, and 13 is the opposite leg, and x is the adjacent leg. So I'm going to do tangent 63 degrees is to 1 as the opposite leg is to the adjacent leg. And since I have an x down here, what I'm going to do is switch these diagonally. X over 1 equals 13 over tangent 63 degrees. And again, I can pull out my chart and find 63 degrees and go over to the tangent column, and I find that it is 1.9626. So I can replace this with 1.9626. Or I can type in my calculator 13 divided by tangent 63, which is exactly the same as 1.9626. And I get 6.62. So x equals 6.62. Okay, and then one more. So here's my angle. Over here is the opposite leg, it's x, and the adjacent leg is 21. So tangent 59 degrees is to 1, as the opposite leg is to the adjacent leg. Now this time, I don't have x on the bottom, I have a number on the bottom. So this time I'm just going to do cross products. 1 times x is x, and then the other cross product is 21 times tangent 59. And once again, I can go to the chart, 59, and then over to tangent, and I have 1.6643. So I could replace tangent 59 with 1.6643. Okay, so I could type in 21 times 1.6643, or I could type in 21 times tangent 59. Okay, now they come out slightly differently because this number is actually rounded. The calculator happens to know more digits of it. But when I round to the nearest hundredth, they're actually going to come out the same. X equals 34.95. Now the calculator version is more accurate than using this decimal off the chart, but they're extremely close. The calculator just happens to know more digits to use than the chart does. So if I actually just typed in tangent 59, I get more decimals than 1.6643. Okay, so this is more accurate, but not by much. All right, find the height of the lighthouse to the nearest foot. Okay, so here's my angle. Across is the height, that is the opposite leg. And right there is the adjacent leg. So I have tangent 62 degrees is to 1, as the opposite leg is to the adjacent leg. Okay, now I could replace tangent 62 with a number on the chart if I don't have the calculator that will do this, but I do have a calculator that will do this. So I'll just use my calculator. So I get h times 1 is h, and then 100 times tangent 62 degrees. So 100 times tangent 62 is 188.07. Now this does say find the height of the lighthouse to the nearest foot. So I want the nearest whole number. So the height is 188 feet. Okay, so we've learned a few different strategies for dealing with right triangles. We have learned Pythagorean theorem, we've learned special right triangles, and now trigonometric ratios. We've learned one of them. We've learned just the tangent ratio. But those three different strategies, they have their own uses, but they actually do all work together. Sometimes if you're able to use multiple different options, you'll come out to the same answer either way. They do work together to find the same lengths. So here we're going to find the value of x with two different strategies. The first strategy I'm going to use is special right triangles. Okay, so this is a 30, 60, 90. So in a 30, 60, 90, the shortest leg is to 1, the longest, the hypotenuse, is to 2, and the remaining side is to the square root of 3. So we've got, for part A here, x is to the square root of 3 as the square root of 3 is to 1. Okay, so our cross products are 1x, and then the square root of 3 times the square root of 3, which is 3. So we actually find that x is 3. Okay, now for A, we're using two different strategies. So now I'm going to use the tangent ratio. So here is my angle, and here's the opposite leg and the adjacent leg. So tangent 30 degrees is to 1, as the opposite leg, square root of 3, is to the adjacent leg, x. Okay, now when I have an x in the denominator, I want to switch these and divide. So x is to 1, as the square root of 3 is to tangent 30. Okay, so we're dividing square root of 3 divided by tangent 30. And it gives us 3. So whether I use the special right triangle or the tangent ratio, either way, I get x is 3. Okay, now find the tangent ratio for a 30-degree angle. Now that I know that this is 3, I can say tangent 30 degrees is opposite over adjacent, opposite leg over adjacent leg, which is the square root of 3 over 3. So that's part B. There is the tangent of a 30-degree angle, root 3 over 3. Now, if I look here, it says 30 has a tangent of 0.5774. So what is the square root of 3 divided by 3? Okay, it's not giving me what I want there. I need to change my mode to classic and try that again. Square root of 3 divided by 3 is 0.5774. 5774. Okay, now what if the shorter leg up here was 1 instead of the square root of 3? So this is gone now, and it's 1. So this is no longer 3. Okay, does that change the tangent ratio? So let's try that now. So the tangent ratio, well, first, let's find that missing side. So we'll use 1 is to 1 as x is to root 3. Okay, so my cross products are x and square root of 3. So this side is now the square root of 3. So the tangent ratio, tangent 30 degrees, equals the opposite leg, 1, over the adjacent leg, square root of 3. So it looks like the tangent ratio has changed when I changed that side. But as I said earlier, the tangent ratio should always be the same for an angle measure. So let's try this. We'll rationalize the denominator by multiplying the top and bottom both by the square root of 3. And I get 1 times the square root of 3, which is the square root of 3. And root 3 times root 3 is 3. So I end up with exactly the same tangent ratio that I had up here. No matter what value I change this side to, the tangent ratio will always be exactly the same.